I'm Yang Ruoyan, and I am in group 32, and my group mate is Fan Feiran. And this is the information of our assignment. And this following factual element that we need to design. This following factual element that we need to design. And industry building are the building used for industry activities, and the single-story industry building are one of the Australian structured steelwork market. And in order to achieve the open space goal, the most common structural type is portal frame. And this picture shows the members of the portal frame. And there are 4 minimum design forces for the industry building and shades, such as the die load, live load, wind, and earthquake load. And there are 4 steps that we need to find the wind load. The first step is to find the die load, which is 0.59 kN per meter, and the second step is to find the live load, which is 0.47 kN per meter. And the third step is to find the wind load, which need to use the Australian standard AS 4055. And we can find the wind speed, and then we find the serviceability limit state is 3.26 kPa, and the ultimate limit state is 1.33 kPa, and then we find the wind load. And the first step is to find the load combination, which are calculated below.
In architecture, structural engineering, or building, a purlin any longitudinal horizontal structural member in a roof except the type of framing with what is called a crown plate. In traditional timber framing, there are 3 basic types of purlin: purlin plate, principal purlin, and common purlin. The first step is load calculation. It's divided the 3 sections. The first one is side load or permanent load. It's including roof sheeting, self-weight of purlin, ceiling insulation, and service weight is including the ducting and other service loads. The second is level load, impulse load. The third one is wind load and including the suction and pressure on the roof. There are 2 types of purlin line load. The first one is inward and another one is outward. And wind use the table 4.1 AS 1170.0. The load for maximum deflection is greater than calculated result. The selected section is safe. And the last step is checking serviceability. It's also an indispensable step. Okay,
we need to design our roof and wall breathing, and firstly we need to find the wind load. And because the given information is 3.8 meters for the higher eve, and we need to find the lower eve, which will use the tangent rule, and the lower eve is 3.77 meters, and then we need to calculate the wind load, and the value of C is equal to 29.17 kN, and the value of T is equal to 29.94 kN. And then we can start to design roof bracing, and we have to find the value of each force, and the F1 is equal to 19.15 kN, and the F2 is equal to negative 28.1 kN, and F3 is equal to negative 2.09 kN. And for the first part, we need to calculate D1, and because the effective line is equal to 8.49 meter and F1 is equal to 19.15, and then we choose the section 101 and 1.6 and times 4 CHS, and then we choose the section 76.1 times 5.9 CHS for S1, and 42.4 times 4.3 CHS for S2. And then we calculate the wall bracing by using the rule of equilibrium of moment, and we find force is equal to 40.55, and then we choose the section 50 times 3 EA.
Okay, let's move on to the next topic, the raft design. we use the rafter material is UB. A rafter is one of a series of sloped structural members that extend from the ridge or hip to the wall plate, downslope, perimeter, or eave, and that are designed to support the roof deck and its associated loads. A pair of rafters is called a couple. In home construction, rafters are normally made of wood. Exposed rafters are a feature of some traditional roof styles, and seem like the purlin design. The first step of rafter design is also load calculation. This time we studied two types of rafters. One is central rafter and another is end rafter, and their load weight is different. The two pictures on the left show top of the beam is under compression, and the right two pictures show this beam for reversal actions. And also use the table AS 4100, and we must make sure the maximum deflection is greater than the selected section. And the central rafter its end rafter is used to the different section. Last step,
And this part we need to design the column supporting the rafter, and we have 4 grooves. And the central rafter of the wind load of the central rafter is calculated below. And the 2 binding moments we calculate, and we have to calculate the load combination by this, and then there are 2 cases we need to think. And at the first case, we find the section which is 250 UB to 25.7, and then we find 2 values of n. And then we start to check the serviceability, and we find which is safe, and we find the design section is safe. And then we move to C2, and we have 2 cases again. And at the first case, we choose the section 2500 UB 25.7, and we check the serviceability. This is safe. And because the end load and the central load have different wind load, therefore the die load for roof is 9.9 kN, and the live load is 4.5 kN. And then we move to design column 4, and there are 2 cases again. And the first case, we find the section is 200 UB 18.2, but when we check the serviceability, this is not safe. Then we choose the big section, which is 250 and UB 25.7. This is safe. And then we design the column 1, and at the first case in designing part, we choose the section 200 UB 18.2, and we find this not safe again. And then we choose the big section 250 UB 31.4, and then we find this safe.